right. So hello everyone. Good afternoon. This is lecture 3 of the Introduction to Agent-Based Models course. And in this lecture, oh my gosh, in this lecture, we will go through some initial commands on Netlogo, and we are going to try to understand the basic agents we have to work with when doing our models. So let's just start. And the first thing I want to talk about is about the turtles. And the turtles are the kind name they gave to the agents, the basic agents on Netlogo. That's mainly because Netlogo came from the programming language Logo, created like decades ago to control a robot that had the shape of a turtle, made for kids. And because of that, as a way of keeping the memory of the origins of Netlogo, they decided to call the basic agents of this new language programming language turtles as well. So we have basically named these basic structures as turtles. They are the main elements on Netlogo. But you'll see that like you don't need to use turtles all the time. We can create our own kind of agents as well. So basically, well, let's start from the beginning. Netlogo, there are like 4 types of agents. So we have turtles, we have patches, we have links, and the observer. And these turtles, the turtles I've mentioned before, they are the agents that basically move around the world, while the other agents we're going to see throughout the course. You're going to see these 4 agents if you go to the command center on Netlogo here and click on this area of the interface. And then here you basically have the 4 agents we can deal with while doing coding on Netlogo. So we have the observer, we have the turtles, the patches, and the links. We're going to go through all of these today. The observer is the second element on of Netlogo. Oops. The observer is the second one. And the observer, he kind of doesn't observe passively. Basically, the observer is like an agent who is above everyone, and he basically gives instructions to the other agents. So it's like God. It's a godlike agent that basically can move turtles and change the environment, the patches, create and destroy links, and do everything. So the observer is kind of the let's say like the master of the programming language here. So when Netlogo starts up, as you can see here, we have no turtles, just get like the world in a black screen, a black square without any buttons or anything else. But like the observer, he basically can create turtles. He is the only one actually who can create turtles. And at the command bar here, you see that the active agent is the observer. In this case, that's us. And to create turtles, we basically use the command create turtles. So it's very intuitive. And like in this case here, we are creating 100 turtles. And as you can see, like we have like a bunch of stuff in here. It's like a circle. And that happens because basically when you use the command create turtles, you create all the turtles on the same spot, which is like the coordinates 0 and 0 for X and Y in the world. So for that sake, we can, for instance, change the environment here for the turtles. And you can say to the turtles, like, would you mind, like, please moving forward, let's say 8 steps. And then when we give the command to the turtles to move forward 8 steps, they basically spread, and they spread basically because when you create a turtle, the turtle is created with a fixed position, but at the same time, the turtle has a random color and a random heading. And the heading here is basically like the orientation of the head of the turtle, like where is the turtle pointing to. And this heading is kind of like the angle, like it goes from 0 to 359 degrees. And that's basically how you define the heading of the turtle. So when you give the command forward, you basically ask the turtle to give some steps forward towards the direction of their heading. And that's why you create a circle, because we asked all the turtles to move the same amount of space. Okay. We can also ask the turtles to go back. So I can even go here and say, look, turtles, now you went forward 8, you went forward too much. Let's go back 3. And then they go back 3. You can even ask the turtles to, let's say, look to the left 90 degrees, and you're going to see that all the turtles now, they're like shifted 90 degrees leftwise. Let's say, oh no, it's not left, let's go right 90 degrees, and they basically go back to their original heading angle. And if you ask them to go right 90 degrees again, they're going to be leaning towards the right. So just notice that like a right and left is not about moving the turtles, just about changing the heading of the turtles. Okay, so as we can see, the turtles, they have different colors, and well, actually it's a very uncommon way to come here all the time, change the agent, and give commands agent by agent. Usually work at the observer scope, like we have like this observer scope, and usually we give commands to the turtles from the observer's perspective, because it's easier. We don't have to keep changing the context of the program. And that's how it's going to work also when we go to the code tab next lecture. So from here, like if you want to ask the turtles to do something, like we can just say ask turtles from the observer's perspective. And I can ask the turtles, for instance, to now move, not move, but like a forward 4, for instance. Let's say if we ask the turtles to move 4 steps forward now, as they're heading a bit funny, we're going to see that the circle is going to open, but now in a different way. Like the turtles are going, pointing like to the right, basically. We can ask all the turtles also to change their color. So I can tell the turtles, look, you're very colorful, but I want all of you to be white, okay? And then all the turtles are going to change their color to white. That's another thing you can do. I can also ask all the turtles to fix their direction. So I can say like, let's move left, let's head left 90 degrees. So you can be pointing to the right place you should be pointing, and then they're pointing out. We can ask the turtles to move backwards. We can ask them to move back 2 steps. Oops. Something funny. Oh, my keyboard is disconnected. I hope it's not hope the battery is not dead. So I can ask them to move 2 back. They're gonna move 2 back. Come on, keyboard. Yes, the keyboard is back. We can ask the turtles to change even their size. So let's say I want the size to be 2 now, so they can even increase their size. And another important thing we can do with the turtles, that we can change their shapes. So the shape here is basically the design of the turtle. So if I just say here, like, let's ask the turtles to go forward. And another word for forward, a shortcut, is FD. So you can just use FD instead of forward. Saves you some keyboard. So let's move them a little bit further, 5 steps. And if I want to change the shape, like we can see that the shape here is like it's like the head of an arrow. That's basically the shape. It's like how it is now. But we can also go here on tools, and they can go here like turtle shapes editor. And when we open this menu here, the Netlogo is going to show us like many different draws that we can have with the turtles. So the turtles can look like a turtle, because these turtles here, they don't look like a turtle. They can look like a truck, like a triangle, like a tree. And you can even add more. You can create your own models, your own draws. You can do whatever you want. So let's say I want the shape of the turtles to be like turtles. That's the name here, turtle is the name of the shape. So if I go here and I ask the turtles, look, turtles, please set your shape to a turtle so you can look like a turtle indeed. Then you're going to see that we have loads of turtles now around instead of arrowheads. Okay, so we can change the colors, we can change the shapes, we can change the size, and we can even change the X and Y coordinates. To change the X and Y coordinates, we can ask the turtles to set their X coordinate to a random X coordinate. And we can ask them to also set their Y coordinate to a random Y coordinate. And in that case, you can see that the turtles now are spread in the world. They're not just like in a circle as we started because of the way we basically created the turtles at the beginning, but now they're just spread randomly. And this command here is interesting because basically we have in Netlogo a very, let's say, that the language is really verbal. So for people who understand English, it's quite simple to understand what the code's doing because you just read it as you speak. But here, basically, what we are saying is like, please set the coordinate X, the X coordinate, to a random number, but it's not any number. It's a random number that it's within all the possible values for the X coordinate. So Netlogo goes on the world, it knows the size of the world, how many patches you have, and then it basically calculates a random number that fits the map. Otherwise, you could like create a random number that basically extrapolates the size of the world. And the same here, set Y core to random Y core. It's like for the Y axis. And as you can see on Netlogo, you don't have like a separation by new line or by comma or comma and semicolon, colon and semicolon. You don't need you don't have these separations. You can basically, like here we have 2 commands in one line, and Netlogo knows which command it should execute at each time, because it knows like that, like when you have the set command, for instance, it expects 2 variables here, one being the variable you want to set and the other being the value you want to set the first variable. So it knows that after it receives 2 commands here, this command is over, so it goes to the next one, and so on. Okay. If we change now if we ask let's say here, ask one of the turtles, like we can even like pick one random turtle. Let's say we want to pick one. Let's do something first here. Let's ask all the turtles to set their sizes to 1 so we can see them better on the map. So now we can see the turtles a little bit better. Let's put the size here 1.5. So they're not too big, they're not too small. And I want to ask one of turtles. That means like the Netlogo is going to get 1 turtle by random. We have 100 of them. It's going to pick 1 by random. Okay? And it's going to ask only that turtle to change. Let's say, let's change the color of that turtle to red, okay? So just notice that like all the turtles are white besides this one here, which is the turtle that basically got affected by the command I just gave to the turtle, okay? So that's how it goes. If you want to know like all the variables every turtle has, you just need to, like, let's say this turtle here, you give a right click on that turtle, and then you can inspect the turtle. So you have here turtle 9. Whoa, whoa, whoa. Come on. You have here turtle 9. Let's inspect it. And when you click on inspect the turtle, I expected to see something here as well. Let's just, oh yeah, it's here. I have to drag it for you. Oh, it doesn't let me show. Oh, come on. Oh yeah, it's here. Good. So when you inspect the turtle, it's gonna open another window. Here it's your turtle like zoomed. If you click here on watch, it's gonna kind of highlight that specific turtle in the world here, so you can see that it's surrounded by and here you can zoom out or zoom in, but like basically your turtle becomes like the center of the simulation. And the turtles have some attributes. It's like oriented object programming. Like you have a who number, which is basically the ID of that turtle. Every turtle has a unique who number that will define like which turtle you're talking about. You have the color, and the color is a number. We're gonna see about it later. You have the heading, so like this turtle here is heading 31 degrees. The X core and the Y core, like those are the coordinates, like the X and Y coordinates on the map. The shape is a turtle. There is no label for that turtle. And the breed here, we're going to see about it later, but the breed is basically the type of agent that turtle represents. It could be like other type as well. If it's hidden, in this case, it's not hidden because you can see, so it's false. The size is 1.5 because we defined it as 1.5. The pen size and the pen mode, we're going to see this in a bit. Okay, so when you inspect any turtle, you basically can see all the attributes that turtle has. And that's a nice way to also follow up with the turtle here. I forgot to stop watching it, so I can kind of, oops, just go and inspect again, and I'm going to stop watching that turtle, so our simulation goes back to normal. Okay, any question about that? All right. Let me see if there is any questions. Oh, it's okay. All right. Well, let's say I'm like tired of these turtles here. I want to create new stuff. I want to clean up everything and start from zero. So we have a command for that as well. Clear all. It's basically the command. Clear all is going to kill all the turtles, reset all the colors, and put everything back to normal. You can also use CA. It's like a shortcut for clear all. CA is like a command that you can also use. And that basically put us like on at the beginning of the simulation. So we can start like from scratch. So let's say that now we want to create turtles. So let's use CRT now. Let's create 100 turtles again. They are again in the middle. They all start at the same coordinates. And now let's just say like we want to ask the turtles to do a lot of stuff at the same time. So I want to set the color of these turtles to blue. I want to set the size of these turtles to 2. I want to set the shape of these turtles to turtle. And I want to ask the turtles to move forward 10 steps all in one go. Okay, so you can do that. Like you ask turtles, you open the brackets, and everything inside the brackets are gonna be treated as commands that will be responded. So when I click here, we're gonna see that we have the 100 turtles, blue, size 2, the shape of a turtle, and moved forward 10 spaces, basically, okay? As I've said, like if I want to clear all, I just do CA, and then the turtles are gone. But that's basically how it goes. So let's create now 50 turtles here. Let's ask the turtles to move forward 10 spaces, so then we can see them better here. And now I want to talk about basically the last attribute of the turtles, let's say the default attributes, because of course you can create more attributes. You can give the attributes to the turtles. Later we're going to see how to do that, which is, and the last command I want to talk about is the pen down. So pen down is basically a command that's used to track the turtles moving. So if the turtle move, it kind of draws the path that the turtles move. And before we go to the command, I just want to teach you why can that attribute be important at some point of the simulation. So let's say I will ask all the turtles here, okay, to follow the following command. So I want to repeat 4, and the repeat 4 command is basically a loop. So it's a command that says, like, please repeat 4 times what I'm gonna ask you to do on the next brackets. So here in the next brackets, I want the turtles to go right 90 degrees, and RT is a short for right. So I want the turtles to head 90 degrees right and to move forward 10 steps. So it's going to repeat this 4 times. And then I close the other brackets here. So I'm asking the turtles to repeat 4 times the following command. Rotate 90 degrees right and go forward 10 steps. If I click enter here, you're going to see that nothing happened in the world. And that's because basically what I'm asking the turtles to do is basically like turn 90 degrees, go 10 steps. Turn 90 degrees, go 10 steps 4 times, which means like they're going to go on a square and go back to their original point. So they're going to just go back to the original point they were before. If we want to see what's going on, one of the ways we can do that is slowing down the speed of the simulation. So we have this slider here that basically controls how fast we want the graphics of our simulation to show us what's going on. So I'm going to put it super slower, and I'm going to give the command again. By the way, instead of typing, you saw that I just showed the command. I just clicked, I just like typed arrow up on my keyboard. Then you have like all the previous commands, like in a Linux terminal. You can also do this here. So when I click here, in a slow pace, you're going to see that the orange guy here, you see, it turned 10 degrees. It's moving 10 steps forward. Let's make it a little bit faster. You see, so it goes 90 degrees, 10 steps forward, 90 degrees, 10 steps forward, and 90 degrees, 10 steps forward. Then comes the second turtle doing the same. So as you can see, if you slow down the simulation, you're going to notice that things happen very slowly, and turtle by turtle. They basically don't move all together. They just move one by one. But as the speed of the computer is quite fast, like you don't see these things happen. But like what I want to say here, like I'm speeding up the simulation now. We want to see this done like today, so we don't want to wait like for 2 hours just to see the turtles going in a square and going back to where they were before. So why are we saying this? Because basically we can draw stuff on Netlogo as well. How do I do that? If I ask the turtles, for instance, to set the pen that they have down, let's just, it's not set, actually, it's just pen down. So I will ask the turtle to put the pen down. When I ask the turtle to put the pen down, it's like in real life. Like they take the pen and they're going to put it down. So if the turtle moves now, we're going to see the trace of the movement. So if I come here and ask the turtles to go on a square again, you're going to see that like we have this beautiful draw now with like the turtles on the original spot they were before, but with the square that they drew while they were like following the commands, they repeat 4 with the right 90 degrees and the forward 10. Okay. Well, if you want to clean the drawing, we also have a command. It's clear drawing. So, and then it's going to clear the draw and keep the turtles on our simulation. But if we like the drawing, let's say we're just doing some artwork here. I want to keep the drawings. I don't like the turtles. I want them to disappear. We have 2 options. We can ask the turtles to set their hidden mode to true. So that's going to basically trigger an attribute that each turtle has, and it's going to put them hidden. So you're going to see that they're going to disappear from the map. So if I ask again the turtles to set the hidden to false, then they're going to show up again. If I really want to get rid of the turtles, we can basically and politely ask them to die. It's quite sad, but well, it's a simulation, so they can die here without any problem. So I can ask the turtles to die. And if I ask the turtles to die, they basically die out. Like they just disappear, and there is no way to bring them back because you eliminated them from the simulation. So those are like the basic commands we have. Like if I want to stop drawing as well, I can always use pen up. So I can ask the turtles to put the pen up instead of pen down. That's going to be like that's basically like get the pen, put it up. So when you move, you don't leave any trace in the simulation. All right, so far, any questions? Just gonna wait for your interaction and then we move forward. Nope. Okay. Next thing it's important here to mention are the patches. The patches are like these immobile agents. And it's weird to call them agents at first, but you're gonna get why later. But like they are like the environment, they are the world. Like each square, like each little square in the world is a patch, and they are like the background of your simulation, or they can be like the environment. And patches are also agents. They're here also. You can also give commands to them straight from here, but as I've said, this is very uncommon. We should always use the observer to send commands. So let's just clear all here, just to start from blank. And let's give some commands now to the patches and see what happens here. So for instance, if I ask the patches to set the P color, it's not color, it's P color, it's because it's the color of the patches. If I ask the patches to set the color to blue, you're going to see that the world is going to change to blue. That's basically how it goes. So each little square in our simulation is going to become blue because each patch was commanded to become blue. That's how it works, basically. And we can even do more like a fancy stuff with that. So I can ask, for instance, the P color of my patches to be fishy score. So that's basically the coordinate, the X coordinate of the patch. Let's say plus the PY core. Okay, we're gonna see that the colors in Netlogo, they're numbers. We don't have like we have the names, of course, white, blue, red, that are the standard names, but the colors on Netlogo, they're like they're basically like this. They're numbers. So we can always find a number corresponding to a color, and we can even use decimals to change the color the way we want. So like here, I'm asking the patches to set their P color, the patch color, and the correspondent color is going to be the sum of the X and the Y coordinators of the patch. So when we do that, like you can see that we have some patterns here. It looks even beautiful, I think. It's super nice. We have some diagonals. That's basically where the sum might be 0 because it's black, and 0 is black for the color scale of Netlogo. And then you have some gradient of colors, like going from black to the color, like the corresponding color. Okay. We can also inspect a patch. Just notice that we didn't create any turtle in here. We're just changing the background, the patches. We can come here and inspect the patch as well. Just notice that this patch here is the patch 1, 0, which means that this patch is at the coordinate 1, x equals 1, and y equals 0. And if we, oops, I did something really stupid in here. Oh, no, it's back. We can also drag the patch here. And you can see that the patch, that patch specifically, we can watch it as well. We can highlight the patch we're studying. And it has the x coordinate, the y coordinate, the color, the number of the color here is 1, because 0 plus 1 is 1. And that's basically it. Like we can zoom out, zoom in, and that's basically a patch. So you can inspect the patch. You can add, you can also add other attributes to the patch as well. So if the patch represents some street, some river, some road, you can add more stuff to the patch. Those are like the basic attributes that all patches share in all simulations, basically, because you can remove those attributes from the patches. You can just add new ones, okay? Another important thing to note is that the turtles, they basically have access to all the patches. The other way around is not true. So let's just clear all, start from blank again. Let's create 100 turtles, and I'm gonna create 100 turtles, and I'm gonna give some commands for them right away. I can do that as well. I can create turtles and ask them to do something in the same line. So I'm gonna say to the turtles that they should set their x and y coordinates to random x core and to random y core. So that's gonna basically give them like a random x and xy and random y coordinates to start, and then we have our turtles just spread randomly on the map. And now, that's very interesting. You can ask the turtles to set the P color. Just notice here that we are not changing the color of the turtle. We are changing the color of the patch on top of which they are. So like we are gonna change the color of the patch to the color of the turtle. So when I click here, you're gonna notice that the patches, they're colored according to the turtle. So if there is a red turtle on top of that patch, the patch is going to become red. If it's gray, it's going to become gray. If it's green, it's going to become green, brown, and so on and so forth. So you can see that the turtles, they have access to the attributes of the patches, and they have even like a rights to change the color of the patches. It's very important to know, because it can become very, very useful depending on which sort of simulation you're dealing with, okay? Another thing we can do here, let me just I'm gonna clear all again. I'm gonna create the turtles, spread them randomly. Let's say I want to ask the turtles to face, forgot to open the brackets here, face XY. What's face XY? It's a command that's going to basically change the heading of the turtles, like the orientation of the turtles. I'm changing the angle to which the turtles are facing. So I want to say, so in this case here, I want all the turtles to face the px core, which is like the coordinate, the x coordinate of the center of the patch on top of which the turtle is. So I'm gonna, and the py core. So in that case here, what I'm saying, basically saying is like turtles, I want you to face the center of the patches in which you are positioned on top. Okay, so in this case here, you're gonna see that most of the turtles, they kind of tilted a little bit, and now they're like all facing the center of the patches. And if I give the other command again, like the command to change the p color, you're gonna see that like the turtles are basically facing the center of the square. Like if you look here, this little guy here, this purple guy here, the arrowhead is pointing towards the center of the pink square. Here, the same for the blue, and the same for the yellow here, and for all the turtles on our map. Okay. Any questions about the patches here? No questions? All right. So then we go to the last part of the lesson today, which is basically the links. So we have agents, we have turtles, we have patches. We saw the observer. We are using the agent observer all the time, and now we have links. And links are, let's say, it's like another level of interaction between the agents, because the links, they don't necessarily respect the position on the on the world that the turtles are positioned, but like it's a way to create like links. It's linked just like the name says. So if I clear all here and I create 100 turtles and I position them, let's say set XY to random X core, random Y core here, Y core. Let's create the turtles here. Let's say I want every turtle to create a random link with another turtle, like just create a link. I can come here and ask the turtles to create link with one of other turtles. So once more, we can tell, like, just for this brief experience with the language, the Netlogo language, that the language kind of, it's very intuitive and it follows a lot the colloquial language we use on our daily lives. In this case here, this command is basically telling the turtles to create link with. Create link with is just a basic command that takes one turtle, like the original turtle to whom you're giving the command, and it's creating a link with another turtle. In this case here, you want to create a link with one of. It means like you're going to create one link with one of the other turtles. And why other here? Because you could create a link with yourself. Like the turtles could create a link with themselves, and that would be a loop. In this case here, the command other turtles basically tells Netlogo that, like, look, I want to create a link, one link with a turtle, but I don't want to create a link with myself. I want to create a link with another turtle that's not myself. Okay? And then when we click here, you're going to see that we have a lot of edges, like a lot of arrows here. In this case here, these edges, they are bidirectional. They're not directional. They're not like oriented. But we could also create oriented and or directed edges here using create link from and to, which are like other two commands on Netlogo to create links. Okay, Netlogo has a huge amount of links. It has a dictionary, basically, like you can always click here and, like, let's say create link to, and it might, oops, say, let me see if it's going to work like this. Yes. So if you like highlight the command you want to study and you don't know how that command works, basically, and click on F1, or like go on help here and look up in dictionary, it's going to basically show the command here and how it works. So you have even documentation inside Netlogo. You don't even need to be connected on the internet. It's like a built-in documentation you have. And like one-off here, it basically tells you like one-off works with an agent set or a list. So that's basically how it goes. You have like one attribute that you basically put on after the command, and it explains how it works, and it even gives you some examples of how that works. Okay. Another thing you can also find here is the Netlogo dictionary. You can always go to the dictionary straight away. Oh, I want to know how to create directional links. So let's see here, create link, and then you have here link, create link from, create links from, create link to, create links to, with, and so on and so forth. So you can go here and create links to and see how it works. You have all the documentation here, and you just need to follow the examples and see how it works. So Netlogo like is a language that like you learn as you go. Also, it has these characteristics where basically as you need a command that you've never used it before, you go to the documentation, you learn it. Next time you possibly will be acquainted to it until you basically get to know how to use everything. We are going to learn like the basic of everything we need to do our models. We are going to learn in here, but like it's limitless, the amount of stuff you can do. Actually, it's limited, but it's so much stuff. It feels like it's limitless, the amount of commands and stuff you can do with Netlogo. And most of the times, you're going to find a very suitable command to do something you need within one line, like one line, or sometimes just one command that in another language, Java or C++ or Python, you would take like 10 lines, 10 command lines to do. So that's quite cool, actually. It's very interesting. And as the language is, it's quite similar to the English language, it makes it even more interesting, okay? Any questions on links here? All right. So this is for lecture 3. I'm not going to extend too much today. I expect to have another. Well, can you give one example of link usage? Yes, if you want to simulate social networks. If you want to simulate the spread of COVID, you need to know to whom people are connected. Like if you want to know like how the virus is spread. If you want to simulate let's say innovation and other stuff on the marketing field, like it's important to know how people are connected, and the connections are going to basically define how things spread in the network. So you have tons of examples. If you want to build roads, the roads have to have links to connect to them as well. So if you want to go from one place to another, the links are very important to define like the path, the best path from the origin to the destination of your let's say your route, and so on and so forth. So it's pretty useful, actually. And most of my research, I use links a lot, because basically my research is social contagion and social networks. We're going to see a lot of examples of that. Okay. I will confirm our lecture on Thursday morning. I guess there is always some appointment or some meeting that the university staff calls us to participate, and if there is none, I will let you know, and we might meet on Thursday morning. Otherwise, next Tuesday we will be together again, and next Tuesday or next Thursday, this Thursday or next Tuesday, I hope we go through the code. So we're going to learn how to make the functions, the procedures, and how to create your go, your setup button, and stuff like that. But as you have like some homeworks, you're possibly going through the tutorials already and getting to learn some stuff in advance. So when we meet together, it's more like to remember you of stuff, and for you also to ask questions if you have any question to ask. All right. So that's the end of lecture 3, and see you next time.